Hey everyone, welcome back to Pine Hollow Auto Diagnostics. We have a 2012 Toyota Sequoia here, the big V8, about 3 hours away, and customer complaint is just one day he started up and it did not want to stay running. It was bogging out like it was lacking fuel. Well, let's read the full customer complaint. Oh, apparently they already fired a fuel pump at this thing. Didn't make it any better. So it's here for us to figure it out. Alright, before we fire this thing up, let's read the customer complaint here. Went to start vehicle one day, idled rough and ran very poorly like it wasn't getting fuel. Bogging, surging, took it to a local shop and they diagnosed it as a bad fuel pump and replaced it to the tune of $2,000. Holy crap. Got the vehicle back and ran fine for a while. Started doing the same symptoms of idling poorly and missing. If you gave it gas, it would bog down and would completely stall. Took it back to the shop. They charged me $85 to look at it again and said they couldn't find anything wrong with the vehicle. Vehicle ran fine after picking it up. Suspected that tech, they were having issues, forgot to plug something back in or missed something, and they quietly fixed it. I was told the only codes that existed were Toyota codes for rough idling and NOx control ECU. At this point, I bought a reman ECU from Flagship 1. So I couldn't find any pointers other than a few forum posts that the NOx control ECU code and symptoms of a lack of fuel were remedied by replacement ECU. That's pretty crazy. After replacing the ECU, the vehicle ran fine for a week, but then started bogging and running poorly again. Seems to be getting worse. The oddest thing is the truck will run okay when it's trying to bog and stall if you floor it. Once it gets out of idle low RPM, it pulls hard like it gets plenty of fuel. However, other times it will just bog and stall out. This time though, actually set a check engine light associated with codes attached, freeze flashing 4 low light, yep. Fuel pump control modules and headsets to replace, another $300-$600. Plenty of live data, something about fuel trims. Bank 2 will be pegged at minus 22% on a warm soak with strong fuel smell. Okay. Get my held at 1000 PM, feel a stutter. Hopefully sort this thing out. Sure is kicking our butts and we need our tow rig back on the road. Okay, so let's scan it for codes, look at some basic live data, fuel trims, oxygen sensors, and see if it's running lean, running rich, why is it stumbling. Alright, just to save some time I did a full health report here. So we're at 189,000 miles and 18 codes in the ECM. Now keep in mind some of these may be repeats. So we have a 300, 2, 4, and 8, so a bunch of misfires. System 2 lean bank 1, System 2 lean bank 2, engine stall history, rough idling. And then they repeat because it could be pending, current, and history codes. So, okay, that's looks like an overall engine problem. System 2 lean, I think we'll chase those codes first. I want to go right into OBD2 data, just basic data, because OBD2 reports the real numbers, not substituted values. I want to see mass airflow, fuel trims, oxygen sensors. We'll go from there. Okay, OBD2 codes. We have the same 300, 2, 3, 8. System 2 lean, pending, permanent codes. Okay, right into live data. And what do we want to select? We'll do throttle position, mass airflow, and then engine coolant temp, engine RPM. Equivalence ratio, bank 1 sensor 1 and bank 2 sensor 1. And then long-term trims for bank 1 and bank 2. We do want to graph the downstream oxygen sensor voltages and short-term trims for bank 1 and bank 2. So 12 data PIDs, that's perfect. We can graph all 12. So check it out, just with the key on, 43% on the long terms, bank 1 and bank 2. That's insane. Let's fire it up. Seems to start up okay. Let's wait for it to get into closed loop. Look, we're running lean already. 1.2 on the equivalence ratio. So we have negative fuel trims on the short term. So plus 43, this is pegged high on the long term, and the short term is taking a little bit of fuel away to make this thing happy. Mass airflow, it's a 5.7 liter engine. We're about 7 grams per second. Okay. Let's put it under a little bit of load. Seems to be okay. Let's take it for a test drive. So just sitting here at idle, plus 45 on the long terms, plus 20 on the short terms. This thing can barely add enough fuel to keep it stoichiometric. So we're still in control here, and it's running smoothly, but our fuel trims are like at the limit. So severe lean condition on the base, fuel map. Let's see what happens when we accelerate here. So fuel trims actually get a little better, a little bit. The short terms go a little negative, but the long terms are still at 45%. So it actually drives not too bad. You don't feel any power loss. So my question is, did they put like flex fuel in this thing? I wouldn't think so, because it's not like they changed habits and all of a sudden this problem started. First thing we have to do is get an accurate fuel pressure reading and compare it to specifications. That's number one, because everything else seems like it works. Mass airflow is reading appropriately. Runs fine, so there's nothing wrong with timing. But we're just way lean on the base map, and it has to add like over 50% fuel. I hope they didn't replace the injectors. I think we saw what happens if you get cheap injectors with that Chevy 2500 HD, the one with the $10,000 parts cannon. This one's only at $2,000 right now, but it's still broken. Alright, let's take a peek under the hood. I took off the plastic beauty cover, and everything looks untouched so far. I don't see a Schrader port to measure fuel pressure. I didn't expect to. Here's the fuel line, fuel feed line. Feeds this rail and then it crosses over here to the other bank. So I think we need to unhook this, install a fuel pressure gauge, and look up the specifications. So on all data, looking up fuel pressure specifications at idle, 41 to 42 psi. All right. So let's plumb in a fuel pressure gauge. There's no instructions on where to do that best. We'll just have to improvise. Alrighty, well, fuel pressure gauge is on. Let's fire it up. It might take a little while to purge the air out because on a hot fuel rail, a lot of fuel squirted out. Let's just say that. Definitely be careful doing fuel pressure measurements on a hot engine. Well, let's see. I'll get this thing over here. And seriously, no fuel prime. A little slow to build. Here's your problem, 25 PSI. Holy crap. Let's purge the air out. Wow, check that out. Goes down to 20. Take it for a quick spin. That's the problem. The fuel pressure is supposed to be 40 right now. Holy crap, we're down to 10. Now we're up to 20. Why is the fuel pressure dropping? Up to 45. What is going on here? This is blowing my mind. Did I pinch my hose on the hood? I don't think so. Alright, let's do bidirectional command on this fuel pump. So, on 90 PSI. Why does it sound so weird? I think we're leaking. Well, look, we're at 45 PSI. Okay, that's 90% duty cycle. And then we're sticking at 33 PSI. Okay. There's another, control the fuel pump duty. And let's select fuel pump duty cycle. Okay. So 25%. I don't think it's running. 80%. 42 PSI. I mean, this is the returnless system, I think. Oh no, wait. There is a return line. That's crazy. Huh. What about that? This is old school. So at 80% duty cycle, we seem to be pretty good. At 25%, I don't even hear the fuel pump run. Let's just run the truck and look at what the duty cycle for the fuel pump is while it's running, you know, normal command, and what the fuel pressure is. Alright, here we go. Let's fire it up. 25. We're at 66% on the duty cycle. Interesting. So obviously that's too low. At 90% duty cycle, it goes to 42. So something is really off here. We have to look up how the fuel pump is controlled. Is there an intermediate module? You know, does the ECM tell the module, hey, command the duty cycle to whatever percent? That controls the current of the fuel pump. Okay. I mean, we're definitely on the right track. It's a fuel pressure issue. Now the question is, well, they already replaced the fuel pump. What else could it be? We have to do a little bit of research and maybe see if we can measure the actual current going to this fuel pump at 90%, at 50%, whatever, 60%. See, right now at 53%, look at that, fuel pressure is dropping. dropping to almost 0. And if we rev it up back to 66%, here, let's try this. So if it goes below 50% or below 60%, the fuel pressure drops off a cliff. What if we put in gear? There, we're at 22 psi at 60%. If we let it go to 53, to like 8, that blows my mind. That's cool. Alright, so fuel pump ECU assembly. So the fuel pump is controlled by this little box that the fuel pump relay feeds power to it, has a ground, drives the fuel pump, and these two wires go to the engine computer, FPC and DI. So let's get to this box. It should be easier than getting to the fuel pump. And I want to put an amp clamp around, the feed or the return wire. I guess fuel pump control. Looks like a blue and a red. And then we can command the scanner with the bidirectional control and look at the fuel pressure gauge. And on the oscilloscope, we'll plot the actual current going to the pump. We can measure the speed of the pump and see if this box is doing what it should. So let's find it. I think it lives under the truck. If we go to components, fuel pump location, fuel pump ECU, so somewhere in the back, probably under the floor. Well, let's see what we find. Alright, so we're under the truck. I got the spare tire out of the way, and it sure looks like this is our little magic box. And oh yeah, look at that rust. 2012. This is like a Ford or a GM. Yeah, that's not, doesn't look very healthy. But here we go. Here's the fat wires, the red and the blue, that goes to the pump. And then we have a ground, power feed, and then the two wires that go to the engine computer. So we don't want to poke any holes in this area, but we can use an amp clamp to just unwrap this a little bit. And basically clamp around the blue wire. See what the current is going to this pump. Alright, here's the setup. Amp clamp around the blue wire. So it's going to be measuring current from this little box to the fuel pump. Then lead going to PICO scope over to the laptop. So 1 volt is 10 amps. Let's command the fuel pump on with the scanner. So let's do full field. There we go. So 45 psi. We'll do off. So, how much current did that draw? About 6-7 amps. And let's look at, it looks fine as long as the power and ground is good. And then we can do, that was 90%. Actuation test. Fuel pump duty. We'll do fuel. Just that. Okay. So let's roll the scope. We'll do 25%. Nothing. It's not sending any current to the fuel pump. What about 80%? Okay, 80%. We're at 42 psi. 25%. Nothing. No current at all. Is that normal? I don't know. Let's just run the truck and see how much current it's putting out at like 50, 50% duty cycle at idle. We'll graph that. So see how important it is to have a dedicated laptop for your scope and a dedicated scanner. Those all-in-one deals just don't work in the real world. I'll tell you that right now. So here we go. So it starts at 90, drops to 66. So we're only drawing 3 amps right now. And then when it drops to, see, we're at 25 psi. Get everything on one screen. Look, when the fuel pressure drops, the current drops too a little bit. Let's wait until it drops to 53%. I'm sure this will drop close to 0 amps. So, are we ready to call the controller? We need to check powers and grounds at the controller. There we go. 53% duty cycle. Look, we're only drawing like 1.7 amps. Crazy. So that's all the data that we need to collect. If the powers and grounds at that control box check out, it needs a new control box. That's it. For some reason it's not putting out enough current to the fuel pump, even though it says, 53%. This should be like 5 amps, not 2 amps. So that's pretty neat data-driven diagnostics right here. 8 psi on the fuel pressure. One more check I want to do is check the powers and grounds coming to this box. Nice bright 5 amp test light. We're going to load this circuit real good. And 11.2 volts. That's perfectly fine. Just a 1 volt drop. Nothing wrong with powers and grounds. I'm suspecting this bad box. Or could it be a defective fuel pump? I mean, the guy said all of a sudden this thing started and a new fuel pump didn't fix it. And that box looks like the rust is about to crush it internally. And a 25% duty cycle command, it doesn't send out any current whatsoever to the fuel pump. I think this box is striking out, this fuel pump control ECU. So we'll see how much it costs. see if we can get one, even a used one from like a Southern vehicle perhaps. But it sure is looking like a bad fuel pump control ECU. Well, here's the suspected bad fuel pump driver module. I tried saving the bolt, I really did. I exercised it back and forth and it still snapped off. Classic rusty Toyota, of course. So how much does this thing retail for? Let's look it up. I'm guessing maybe $250, $300. $420 for basically a little power transistor. This is ridiculous, and it lives in a terrible area. So every 10 years, you just have to pay that Toyota tax, I guess. So that's it. We need an OEM unit. If you look this part number up, like, oh, let's go to eBay. Toyota genuine fuel pump controller. Yeah, looks great. Amazing. Shipping from Japan? Really? Well, computer, fuel pump. Hey, that might be the genuine item. I don't know. There's the part number. Does it match our part number right here? Yeah, it does. So I wish I had a known good Tundra here that I could do the same experiment on to be 150% sure that it's this module, but with a fuel pump that's questionable, and this thing is definitely questionable, you know, which one do you replace? I'm going with this module because it's not a fuel pump problem. So we'll get one coming, talk to the customer, see so you get this truck back on the road running smoothly.